Hello, students. Today we will be discussing about another topic under graph traversal. In the last video, we were discussing about BFS, and in this particular session, I think we will be discussing about. It's not. I think I we are going to discuss about which is called as DFS. Right? If you have any if you want to learn about BFS, please do check the, uh, you know, the previous video of mine so that you will be able to understand what exactly BFS is. And then it is not necessary that you have to know BFS to solve DFS, nothing like that. So we are learning a topic under graph and graph traversal. One technique we already learned, which is called as BFS. I've solved the problem as well. So you can check that particular video link. And in this particular class or in this particular video, we will be discussing about DFS. That is also another technique. So let me just quickly tell what traversal is all about. I think I already mentioned telling what is traversal. Traversal is simply from a word called as travel. So basically, you travel across every node exactly once. You're not supposed to repeat visiting the node. Only once only you should be able to visit the node, and you have a sequence of visiting every node. So one of the sequence, the technique to identify the sequence is called as breadth first search, which you can actually check in the previous video. Uh, but today's class, we will be discussing about another technique to visit every node exactly once. Another technique is called as depth first search. This is the second technique that we will be discussing, which is called as depth first search, DFS. So let me just quickly talk about what DFS is and try to make you understand what DFS is all about. So you have to take a piece of paper and be ready to solve the problems as well. Right? So let me give you a basic introduction about DFS. What is DFS standing for? Depth. Depth first search. First search. Right? What is this depth first search? Given a, the first point that you have to remember is given a graph or a tree. Let us assume this is like a tree. We will identify how to solve depth first search. Depth first search will always search or visit every node depth wise. It will search. So it will start from here and it will go, deeper and deeper till it finds or till it reaches to the last node of that particular depth, or we will call it as a leaf node. Once it finds the leaf node, it will backtrack, it will go back, and it finds another depth, and it'll go back, it'll find another depth. So it basically it will travel or visit every node depth wise. It will keep visiting till the last node. The last node is also called as leaf node, till it reaches the leaf node. Once it reaches to the leaf node, it will go back, or we'll call it another technique called as backtracking. It will do a backtracking, and once it goes back, if it finds another node, okay, there is another deeper node, it will travel or visit that particular node, backtrack, and so on. So the major difference between BFS, if you want to learn that, check that particular video. BFS is level wise; it will search. When it comes to DFS, it will always search, or it will always visit depth wise. It will keep visiting. Yeah, that's the first point that you have to remember in case of DFS. Second point that you have to remember, which data structure is used to solve DFS problems? The problems can be solved using a concept called as stack, right? We will call it as stack. This is one of the data structure concept. I'll quickly tell what exactly stack is. Stack uses operation called as, or the concept called as push and pop. Push means you push the element onto the stack. Pop means you remove the element from the stack, right? So once you push the data onto the stack, imagine there's a number that you're pushing. It's think that 5 is being pushed. The next number that will be pushed is 6, or your choice, any number. Next number probably 100, okay, and the next number is 90. Now if I tell you to delete or pop, so what is the first number that you will pop? Whichever is in the first place. Can you see that this number, this will be popped? And if I tell you to pop the next number, 100 will be popped, and next 6 will be popped, and 5 will be popped, and so on, right? So what do you understand from this? But which was the first element that I pushed? 5 was the first element that I pushed, and 6 was the second element, third element, fourth element. Which is the element that I pulled first? Whichever came last is the element that I, popped out first. So can I tell we can use the principle called as last in. Whoever came last, he got the service first done. So last in, first out. We can also tell the principle that stack uses is called as LIFO. What is LIFO standing for? Last in. Whoever came last got the service done first, and left. So last in, first out. Right? We can also tell first in, last out. Whoever came first, he is the last person to leave. Either LIFO you can tell, or FILO. FILO. What does FILO stand for? First in. Okay, the 5 came first, but he will be the last person to leave. That is also a right principle, suits this particular concept, or you can call it as LIFO. What is LIFO? Last in, first out. Whoever came last will be popped out first. So these are the two things that you have to remember when it comes to the DFS. What is the DFS? And also, I want to give you a small hint to remember, to always use the stack. Don't forget stack. Don't forget stack. In DFS, you will be using stack, but in BFS, you will be using queue. So that is why I'm giving you a hint. Depth first search. Don't forget stack. So DFS. Don't forget the stack. So can we just solve the problem so that you will be able to um, you know solve any kind of a problem which is given in the question paper. So did you take a piece of paper? Let me just draw this particular diagram, and you also draw with me. This is one. We are going to do DFS, right? I'll just make a DFS in graph traversal, right? So this is node 1. This is okay. This is node 0. I'm connecting it to 2. I'm connecting again to the node 1, 3, and one more node, which is 4. Okay. I hope you also finished the drawing with me. And if it is mentioned to start from the root node 2, then what is the first element that you will be pulling onto the stack? That is called as 2. You'll start with 2 because in the question it will be mentioned. If in the question is mentioned you have to start from 3, then please start from 3. If nothing is mentioned, then the choice is yours. You can start from whichever node you want to start. And I'm going to start from 0 because 0 is my favorite number, 0 the hero. So I will start with 0 because in the question I only have a graph, and I've mentioned, or in the question is mentioned, it is DFS. Graph is given, but nothing is mentioned from where you have to start. So you can start from wherever you feel like starting. So let me just write the result. Okay, this is what the result is. Will be printed on the screen, right? I want you to carefully listen. And then this time we will be using a concept of stack. We will not use the concept of queue, but then we will be using a concept of stack, right? So I have drawn a stack. Which principle it follows? Last in, first out. Whoever is in the last, you will pop that first, right? So because I have not mentioned from where to start and which node to start, so I'm going to start with 0, right? I will push 0 onto the stack, right? and I will print it on the output screen, right? Because there is no other element, only 0 is there. So I will print 0 onto the stack. This is little different from DFS. So I want you to carefully listen the technique. So you can also solve the same, method that, I'm trying to follow. So I started from 0. I pushed 0 onto the stack and I printed onto the screen or printed on the result. Now you have to try to explore the friends of 0 or the adjacent node for 0. What are the adjacent nodes? Just identify the lines that is going out of 0. There are two lines that is going out of, so basically 0 is connected to 1, 0 is connected to 2. Another important thing that I also have to mention is there could be students who might be thinking, why should I write 1 first and then 2 second? Can I write 2 first and then 1? Yes, it is possible. There is nothing like there is an order that you have to write. So just identify the adjacent nodes. Either you can, so what are the adjacent nodes that we have? 1 and 2. So either you can start with 2 and then write 1. There's no issue. But you make sure that you write all the adjacent nodes. The order doesn't matter. So I started with writing 1 and then I wrote 2. If you want to write 2 comma 1, go for it. No issue at all, right? So these are the two adjacent nodes for 0 or friends of 0. Now you can't pull both the numbers onto the stack. You can only explore depth-wise one particular element in detail. So what I will do is, whenever I put a tick here on top of it, I will explore or I will go in depth for one, right? I'm not going, I'm not going to put both the numbers onto the stack. I will only put one and go in detailedly, try to go in depth. So that's why I put a tick. Once I put a tick, put it onto the stack and print it on the output screen as well. What did I do? I am going to explore. I decided to explore. The choice is yours. You can explore either one or you can explore two, but I am going to explore one in detail. So I put a tick over here and I push that one onto the stack here and I print it on the output screen as well. So once you put the tick, pull that number onto the stack, put it onto the result as well, right? Okay, let us try to explore the friends of one, right? Let's try to explore the friends of one. Okay, adjacent nodes of 1. Okay, look at 1. Okay, 1, there is 2 lines that is going out. That means it is connected to 0. It is connected to 2. Correct? It is connected to 0 and it is connected to 2. Now let us try to explore one of them. I will explore, I will try to explore one of them, 0 or 1, right? 0 or 2. 0 or 2. Now see, 0 is already printed on the result, already is part of, is part of the stack and, it's got printed on the result. So no need of, exploring 0 anymore because it's already displayed on the output screen. No need of exploring 0. Now what is the thing that has to be explored? I am going to explore the number 2 because I put a tick over here. I put it onto the stack. Don't forget to put it on the stack. And I will write it on the result part as well. Because I put a tick, I'm going to explore this too. Put it on the stack, put it on the result. Right? Okay. Now let us try to explore two. Try to identify the adjacent nodes for 2. Oh, it has so many friends. 1, 2, 3, and 4. Right? Okay, 3 lines are going on. Okay, so 2 is connected to 1, 2 is connected to 0, 2 is connected to 3, 2 is friends with 4 as well. Right? 1 is already part of the result, already processed and got the result. Okay, no need of, bringing that onto the stack. 0 is also part of the result already. Then why are you exploring 0? No need of exploring 0. Now, what are the two things that is not part of the result? That is 3 and 4. You can't put both the number onto the stack. You should only put one number onto the stack. So I put a tick for 3. I'm going to explore 3. put it onto the stack, put it onto the result as well, right? Now, you can also explore 4. It's your choice. But you can explore, if you're exploring 4, you can only explore 4. You can't explore 3. Any one only you can select from that. I selected 3, right? So now let us try to explore 3. Try to identify the friends of 3. Okay, 3 has only one friend, correct? There's only one line that is going out of 3. Can you see that? It's connecting to 2. But 2 was already printed in the result, so let's not bother. Now there is no item that should be put onto the stack. That means we have to pop. You listening, right? There is nothing that I am able to explore further, right? I am not able to put a tick and explore and push it onto the stack. So what I will do, I will pop the element whichever is there on top of, which is the element that is there on top of the stack, that is 3. I will pop it out. Now what are the elements that we have? 2, 1 and 0. Correct? Now try to explore which number, what is the element that is in 2. Okay. To explore 2 and tell me what are the nodes or adjacent nodes that is connected to 2. So it's already written here, but let me write again. 2 is connected to 1, 2 is connected to 0, 2 is connected to 3, and 2 is connected to 4 as well. 1 was already part of the result, 0 was also part of the result, 3 was also explored, right, and got the result. Now what was not explored? That was 4 was not explored. So now I put a tick for 4. I have to push it onto the side. Let me draw once again. 0 was there, 1 was there, 2 was already there. Now who comes? 4 comes, and I have to write it on the result as well. Right? We are trying to explore 4. I'll write over here. Right? I'm trying to explore. Tell me the friends of 4. There is only one line that is going out of 4. Yeah, it's connecting to 2. There is only one friend. Right? Now let us try to explore 2. But 2 already was in the result part of it, it already got printed. Why are you going to explore when it is already explored? So there is nothing that has to be pushed onto the stack. There is nothing that has to be explored. Now pop that number which is there on top of the stack. What is the number that is there on the stack? Okay, pop that 4 out. Now what is the number that we have again? We'll try to explore 2. Okay. 2, we already know how many numbers are there. Okay. 1 is an adjacent friend, 0, 3, and 4. 1 already got processed and printed on the screen. 0 already printed. 3 already printed. 4 already printed. So basically nothing has to be pushed onto the stack. So do the pop. What can be popped now? 2 can be popped out. Right? What is the remaining thing that is there on the stack? Okay, let's explore 1. Okay, tell me what are the nodes, adjacent nodes for 1. 1 has only 2 nodes, that is, it's connected to 2 and it's also connected to 0. Now see if it is already explored and printed on the screen. 2 is already explored and printed on the screen. 0 is already explored and printed on the screen. So there is nothing that has to be pushed onto the stack. So now we will pop, right? Pop the element 1. Now, what is the element that is there remaining? 0. Now, see 0, explore 0. Go to 0 and find out what are the nodes that we have. That is 1 and 0 has friends with 1 and 0 is friends with 2. Okay. Let us try to, okay, 1 is already printed. No need of exploring that. 2 is already explored. No need of, nothing is there. So, can I just pop out 0? Now the stack is empty. Once the stack is empty, that means you understood that we visited every node. What is my result? This is the sequence that it visited in DFS. The final answer will be 0, 1, 2, 3, and 4. Every node is visited exactly once, no repeating, nothing. If it repeats, no, it cannot repeat. The rule will become invalid then, right? It should visit every node exactly once using a technique called as a DFS. This is the sequence that it visits 0, 1, 2, 3, and 4. Right? So we use the concept of stack. If you haven't understood, just rewind the video, and I'm sure you will be able to do it by yourself. Try to take another problem and try to solve that particular problem. If you have any doubts, you can definitely drop in your questions, or your graphs. If you have any doubts, drop into that particular email, and then I will be very happy to help you. Thank you so much.